Hi, everyone. Thank you for joining me on the first review for grade 9 math. And this is 3 parts with regards to this session. So on chapter 1, we're going to be doing numbers and operations. Chapter 2, we're going to be doing powers and exponents. And chapter 3, we're going to be doing, chapter 2, sorry, is rates, ratios and percentages, and chapter 3 will be powers or exponents and monomials. So let's get right into this first review. So as you can see on the screen, we have the different problems that we're just going to be solving. We're just highlighting a few and just as reminders of what we need to look for when we're doing these questions. So as you can see, the first one says +4 minus -9. And remember what happens when you have two negatives, it becomes a positive. It's almost like saying -1 times -1 is positive. And so because two negatives following each other, it behaves as though you're multiplying the negatives. So it becomes a positive. And in that case, we're going to say 4. So if my screen can work, so 4 plus 9, okay? And then that would give you 13. So the answer is 13. Pardon my writing. And then the next one, to the right, we have -3, -12. So, and also bear in mind the number line tool, we can use that. So remember, if you start at -3, you're going to be going negative, which is going to the left. So you start at -3, you're going to go left on the number line, but because you're going to be going negative again, you're basically reversing the order. So when you have two negatives, you're going to reverse the order. So instead of going left, you're going to go right. So you start at -3, you go right. So basically you're saying it's -3, okay? And then you're going to add 12. So instead of -12, you're going to change it because negative with a negative becomes a positive. So then that answer, if you guess 9, you're correct. So the answer is 9. Okay. So I know my screen is not working properly, but you got what the answer is. It's 9 there. Now, when we have a multiplication in the next section, it says evaluate. And the next section says 15 times -3. And remember, a negative times a positive is a negative. And if you remember that rule, you'll remember that the sign is going to change regardless of what the other sign is, because even though 15 is a bigger number and it's positive, it's this negative that's carrying the weight, which is going to be -45. Okay, so it's really -3 that's carrying the weight. So the answer is -45. Okay, so if we move to the right, we see a -72 divided by a +6. And with regards to remembering our multiplication table, we have to have that ready. You can't be just trying to figure it out by counting. And I know some people don't like to study their multiplication table, but if you do that, then it's very easy when you're doing these questions. You just need to say 72 divided by 6. And the fact that 72 is negative, then that will carry the weight. And 72 divided by 6 is equal to 12, but it's a -12, okay? Then we go down, +5 plus -3 plus -12. As you can see, the plus does not bear a lot of weight, so it's really the negative that's gonna carry that. So we're actually gonna rewrite this by saying 5, okay, -3. And then you also see the same thing applies for the plus negative 12 here. So we know that's going to become negative 12. And you can see right away there are two negatives in the group, which will bring it up to, you actually, when you have two negatives side by side, it behaves as though you're adding. So remember that quick rule. So when you have two negatives, so we can just simply just say -3 and -12 is -15. And then we're just going to add 5 and -15. But because we're going in the opposite direction on the number line, you're basically starting at 5 and you're going to go 15 steps to the left, which means you're going to end up at +10 and -10, sorry. Yes, -10, because you're going in the opposite direction. So the answer is -10. Let me rewrite that because I know it doesn't look that clear. So the answer is -10. Okay. Oh, that makes sense. And then on the other side, we have -72 divided by +6 times -5. And if you notice, the question above has the same similar part of the question where it says -72 plus divide by 6. So because we already know that that answer is -12, so we're just going to put -12 for this section. So we're going to say -12. I've got my equal sign. -12. And then now we're going to multiply that by -5. Okay. And that will become, because we have a negative times a negative, remember what that rule is? It's positive. So 5, 12, 60. So the answer is 60. So we don't need a negative anymore. Okay. Now, if we say calculate, and this is now fractions, remember the fraction rule. When you have the denominator is showing different numbers, you can't just simply do anything with the numerator. You have to find the lowest common multiple. And in this case, you can do your multiplication in your head, however you choose to do it. But in this case, I can tell you right away that the lowest number where 3 and 5 can go into without leaving a remainder is 15. So you have to convert the fractions into fractions that would have denominator as 15. So this is how you do it in a short about way. So you're going to put the 15 at the bottom, okay? And you're now going to divide out the denominator. So you're going to say 5 divided by 15, and that's 3. Then you're going to multiply the answer you get with the numerator. So 3, 2, 6. Okay, so the answer is 6. And then you're going to subtract because you're doing that with the fraction itself. You're going to say 3 into 15, that's going to be 5. And 5 times 1 is 5. So you're going to have 5 as your number that you're subtracting. So now we have both numbers are using the denominator as 15. This is almost the same thing as saying 6, and if my pen would write proper, 6 divide over 15, okay? And then you're going to subtract 5 over 15. And it's very clear. The answer is 1 over 15. Okay, and that's it. The same thing applies for this question, but if you notice that your quarter is negative, and then you have the 2/3 over here. So another way of doing that, you can switch it around if you want, or we just let it be. We'll just let it stay the way it is, because it may not always work out that way where, you know, the first number is smaller. So in terms of portion, and I'm not sure if we talk about absolute values, but absolute values is when we don't even consider the negatives. We just look at the value of the number. before we even consider the sign in front of the number. So in this case, we're just going to keep the sign and we're going to use the same rule. So we're going to say the lowest common multiple is 12. So in this case, we're going to put 12 at the bottom. Okay. And then we're going to keep the negative and we're going to say 4 into 12 is 3. 3 times 1 is -3. Okay. Because remember, we have to use the sign at the front. And we're going to keep the sign that follows the next fraction. So we say 3 into 12 is 4. 4 twos 8. Okay. So that's 8. And again, just do the same principle. It's just like saying -3 over 12 plus 8 over 12. And when we take a look at that, we can see that it's going to be a positive number because 8 is a greater value. So it's like saying you start -3 at the number 9 and you're going to move 8 spaces to the right. If you do that on the number line, you'll see that the answer will be 5. So your answer will end up being 5 over 12. Now, this question is a mixed fraction. So it's another way of saying 2 1/4 divided by -2 2/3. So there's a lot of things happening in this question because first we're having mixed fractions, mixed numbers. And if we have mixed numbers as a fraction, then we have to convert it to an improper fraction first. So the first thing we're going to do, we're going to convert the 2 1/4 to an improper fraction. Remember, you multiply the denominator by the whole number and then add the numerator. Okay, so let's just do that in a roundabout way. So we're going to say 4, and then we're going to multiply the 4 times the 2, and then we're going to add 1. So that's what we're actually doing, okay? I'm only doing that one so you can see how we do it. So 4 times 2 is 8. 8 plus 1 is equal to 9. And then we're going to keep the numerator, which is 9 over 4, okay? And so the next mixed fraction is 2 over 3. So we're going to say 3. We're going to multiply that by 2. And then we're going to add 2. Okay, so you can see that my writer, okay, I'm just going to change that. So it's 3 times 2. And then we're going to add 2. Okay. And in this case, we know that the numerator is negative. So this would have been -2 here. Okay. The whole number, I should say. So 3 times 2 is 6, -6, and -6. Actually, in this case, we have to use we have to treat it as an absolute value. We can't use a negative inside here, only because a mixed fraction cannot be devaluated, like it cannot be reduced, right? So it must be the absolute value of it that we have to find, and then we're going to put the negative on the outside. So let's start that again. So it's 3 times 2 plus 2, okay? So it's 3 times 2 is 3 to 6 plus 2 is 8. So the whole thing becomes -8, and that will be over 3. Now, as you can see, we have the mixed fractions complete, or the improper fraction converted from mixed fractions. So now we're going to put them as though we would have done our regular dividing. So we're going to say 9 over 4. And then we're going to say divide. I like my divide sign. So divide by 8 over 3, okay? If you remember your rule, when you're dividing a fraction, in order to ensure that we get the right answer, we have to do the reciprocal of the second fraction and change the sign from division to multiplication. So now we're going to say 9 over 4, and we're going to put that multiply by 3 over 8. And remember, it's negative. And I just have to ensure that we remember that. So it's negative 3 over 8. Okay? As you can see, the 8 over 3, the reciprocal of 8 over 3 is 3 over 8. And then now the only thing left to do, we're just going to multiply the numerators and multiply the denominators. So 3 times 9 is 27, and now it's negative 27. And then we have 4 times 8 is 32. So there is your answer. And as also you can see that the fraction now becomes a normal fraction. It started as an improper fraction, but now it becomes a normal fraction. And that will be what we have for grade 9, chapter 1. And this is regarding numbers and operations. So now let's look at chapter 2 with regards to rates, ratios, and percentages. We have 27 as a percentage of 35. And what is that number? Is basically what this is saying. 27% of 35 is what number? So if you're going to do it the long way, we can simply say 27 over 100, okay? And then we're going to multiply the 35, okay? And that's a good way of doing it. And going back to what we just did in the previous session, when you're doing, when you're using a fraction, you just simply multiply the numerator when you have two numbers, and it can be posed as a fraction. Remember, every number can be expressed as a fraction. So in this case, because 35 is a whole number, you can simply put it over 1. So this is acceptable if you do it like that. And this is a long way of doing it. I mean, we can use our calculator to find it, but this is another way of just learning how to work with long numbers. And if you do your long multiplication, then you will find that it would be 945. Okay? And so, because we're dividing that by 100, so we're simply, if you remember what we talked about in one of the units, when you're multiplying or dividing by numbers that have zeros, you can just move the decimal place. So in this case, because we have 2 zeros, we just need to, and we're dividing. So remember, there's an imaginary decimal place after the 5. So you're going to move 1, 2. So your answer will automatically become 9.45. And it's as simple as that. So 9.45 is your answer. Okay. So here we have what percentage is 15. What percentage of 15 is 12. So when something is of the other, well, in this case, this is the big number. And then we're finding this as a percentage of that big number. Okay. So the smaller number in this case will be the numerator, and the bigger number will be the denominator. And the same way we just did our percentage, we're going to use fraction again. But in this case, because we don't have, we need to find a percent, so we have to do the flip way of how we express it in the previous question. So here the 100 becomes the whole number, and we just put it over 1. So now we have to multiply both at the top, which is the numerator. So again, simple way of multiplying numbers end with 0. Once the first number is a 1, you just either add if you're multiplying the zeros, or reduce a 0, or reduce the decimal places if we are dividing. So in this case, because it's 12 and we're multiplying, we're just simply going to add the 2 zeros and it becomes 1200. Very simple. We don't need to use a calculator. Okay. And now we just need to carry the 15 because 15 times 1 is 15. So in this case, we're going to say 15 is going to be divided into 1200. And you can either do the long division or you can use your calculator for that. And if we're going to divide 15 into the 1200, the answer will be 80. Okay. Okay. So now we go to the next question, which is ratio. In this case, we need this information to find the answers. So here we have groceries that spent is $250. We pay $80 for cable and we pay $5 for the phone bill. So the question is asking ratio of groceries to phone bill. And if you notice, groceries came first and then phone bill came second. So the simple way of doing that is making sure that you keep the ratio exactly the same way that it's being asked in the order that it appears. So if they say groceries first, that means the first one you're going to put down is the 250, which is your groceries. So in this case, it's going to be 250. And then the second one is phone bill. So in this case, phone bill second. So it's going to be 55. And when you're doing ratios, simply you put the colon in between the two numbers. So it's 250 to 55. And that's your ratio. You don't need to do anything else. And in this case, they say find the ratio of the total to the cable bill. Now, in this case, it's the whole to part. So we have a way of expressing ratio. We can say part to part or whole to part. So in this case, the first one was actually part to part. That means part of the group is expressed to another part. But in this case, it's whole to part because whole means the total of all the group to one part. And so the whole will come first in this case. So the first thing we have to do to find the whole is to add up the total of all the expenses. So the first thing we have to do is say, okay, 250 plus 80 plus 55. And what is that answer? Okay, so we have to add 250, 80, and 55. And then that will be equal to 385. So once we know it's 385 as a whole, then we simply have to use that as part of our answer. So we're going to put the 385 first because that would be your whole. And then we're going to keep our colon because the colon suggests that there is a ratio expressed here. And then we put the cable bill, which is 80. Okay, so you spend $80 on the cable, and that would be your answer. So it's 385 to 80. So the next question is pertaining to rate. So it says if the rate on commissions earned is 2% on every $1,000 sale, what is the amount earned on 24,000 based on this rate? So there are different ways to find this answer. We can simply just say, okay, how many $1,000 can we find in 24? Okay, or we can start by saying if 2% is on every $1,000, right? Then we can find what the 2% of $1,000 is. We can do it that way. So let's do that. So if we say 2% on $1,000, automatically, remember what I said when you're doing, you can literally move the decimal to the point where you're just moving it to find the answer. So 2% represents another way to say 2%. So let's do that first. So 2%, another way to say that is the same as saying 2 over 100. Okay, This is just extra information. 2 over 100, or you can say it's equal to 0.02, right? And the reason why you know that is because if you divide 2 by 100, you're moving the decimal place 2 times, and you're going to get 0.02. So 0.02. And the simple way of doing that now, you're going to say 0.002, okay? And then we're going to multiply that by 1,000. Okay, so this is just for review and just so that you can remember how these questions are being done, and also to have like a insight understanding of what you need to do to find the answers. Okay, this is just to provide some clarity. So we have 3 zeros here. So we're going to move the decimal place 1, 2, and then 3. Sorry, that's the wrong way. We're not dividing, we're multiplying. My apologies. So we're moving the decimal place to the right. So it's 1, 2, 3. Okay. So now we're going to fill in that spot. So 2% of 1,000 is 20. Okay. So if we know that $20 is earned on $1,000. Okay. We know that, right? How many $1,000 do we have in 24? If you say 24, the answer is correct because we have 24 $1,000 here, okay? So the simple math, we're just gonna say 20 multiplied by 24, okay? And then we get the answer. So we just need to add a 0 and then we multiply the 24 by 2. So 24 times 2 is equal to 48, and then we add a 0. So that would be $480. Okay, and that would be your answer. So at 2% rate of $24,000, you're basically, and if you, yeah, so that's how you have to do it, because you can't just simply say 2% on 20. If you say 2% on 24,000, well, you could do it that way too. But the point is, it's on every $1,000 sale. Because if you had a different amount, then that would change. So it's really on every $1,000, okay? And so in this case, $1,000 will give you $20, and there's 24 $1,000, so you multiply it by that, and then you get the answer here, okay? And that's it for chapter 2 in terms of rates, ratio, and percentages. And here we're going to be doing chapter 3. So this is supposed to be chapter 3. So chapter 3 is powers and monomials. So this is really exciting because now we're working with powers. And remember, powers is another name for exponents. And so if you remember your BEDMAS, some people might be wondering what E stands for. E stands for exponents, which is the same as powers, but to make it simple in terms of remembering the word BEDMAS, we use E for exponents instead of powers. So here we have 2 to the power of 7 times 2 to the power of 8. Note carefully that when you have two numbers that have the same base, you simply add the powers. So in this case, 2 to the power of 7 times 2 to the power of 8, we simply add the powers. So 7 plus 8 is equal to 15. So if that's what you said in terms of how you express that, that's correct. And you can pause the video and do the questions and then look and see what I've done for the answers afterwards. So here we have 12 to the power of 9 divided by 12 to the power of 6. If you notice, in this case, we're dividing. When we divide, we subtract the powers, okay? When we multiply powers, when we multiply bases with powers, we add the exponents. When we divide bases with powers, we subtract the exponents. So we're just going to simply subtract the 9 and the 6. 9 minus 6 is 3, so the answer will be 12 to the power of 3. Okay? Here, as you can see, this is one of those strange questions that we did before. And if you notice, the 4 inside the bracket is the exponent. The number is positive, so that we have to use the absolute value. And another thing, we notice that we have to the power of 5. If we remove the bracket, then we're saying that what's on the inside is -4, but because we're using this as outside of the bracket, and we're saying 4 inside, okay? And we're saying that this to the power of 5. So what we have to do, we have to put the bracket outside and we have to multiply 4 5 times. Okay, so that means the answer will be 4. I mean a negative, sorry. And the reason it doesn't matter what the exponent is on the outside in this case, because the sign is on the outside of the bracket, then whatever is in the bracket must be an absolute value. So it does not matter what the exponent is. Remember, when we have exponents that are odd numbers, it can determine what the sign is going to be if the sign is inside the bracket. But if the sign is on the outside of the bracket, and even if the exponent is an odd number, the sign on the outside of the bracket will dictate the value of the number. So in this case, we're going to put 4 to the power of 5. And we know that that will be 1024. So because the answer is 1024 as the result of 4 to the power of 5, we just need to bring that to a negative. So the answer is negative 1024. Now, to the right, you can see that 7 is expressed as to the power of -12. And when you have a negative power, it's automatic that your number will be a fraction. So you're gonna have, and normally we don't express numbers to negative powers. So you have to convert that to a fraction to express it properly. So that's the right way of expressing that number. And so the result of 1/7 to the power of 12, well, that's a big number. So we'll just leave it at that, because this question actually did not ask you to solve. It says evaluate. So in a case where we need to evaluate, we can evaluate. So 7 to the power of 12 is actually something like 13 trillion. But we'll just leave it as 1/7 to the power of 12, okay? Now, the next question is 6 to the power of 3 times 3 to the power of 6 to the power of 5. So you can see that everything outside of the bracket, everything inside the bracket is multiplied by what's outside of the bracket. So basically, whenever you have a bracket, that's the only time you multiply the exponents. Remember? So the 5 to the power of 3 multiplied by 3, and then 5 multiplied by 6. So remember, you don't, in this case, what we did up here, that's not the procedure for this question. And again, if you notice that 6 is a base number and 3 is a base number, so we can't have it expressed as adding exponents. We cannot add the exponents. So now we have to say 6, and we're going to express, so 3 times 5 is 15. So we're going to say 6 to the power of 15 multiplied by 3 to the power of 30. And we just have to leave it like that because we're basically evaluating. So that's how we have to leave the answer, because as you can see, when we get up into the higher powers, it does not, it's not necessary to express the numbers because that's why we need scientific notation, because it's hard to express numbers in a long form. So we don't express those as though we solve it. So this is just to evaluate the number. Here we have 6 over 15 to the power of 4. So whenever you have numbers that are inside a bracket, basically what you're left with is 6 divided by 15 to the power of 4. It's almost as saying 6 to the power of 4 over 15 to the power of 4. And we can just leave it like that. That's all we're doing. Because a fraction, it's in the bracket. And so because the fraction is in a bracket, then each item within the bracket is expressed in relation to the power on the outside of the bracket. So here the same thing applies. If you notice, we talked about that in this question up here. So here we have the flip side. Here we have -5 inside, and then that is to the power of 5. So because we have -5 as a base number, so we're gonna have to do -5 5 times. So it's -5 times -5, right? Times -5. And then 2 more times -5. And then times -5. And what we just said stands true when there's a negative inside the bracket. The power on the outside determines the sign. So because we have an odd number, which is 5, it determines that the answer must be in a negative format. So that's why even if we don't do, well, we just have to leave it like that once we find what the value is. So let's just do that first. Let's find what -5 to the power of 5 is. And we know that that will be equal to 3,125, and that's a negative number. Okay, so let's try that first. Now, also, you can see that we have a negative, a number on the outside of that bracket. So another way of doing that, before we even find what this answer is, we can just say that this again is to the power of 7. But that also would cause us to expand the number too long. So we don't need to go through all of this. We don't need to go through all of that. And we don't even need to go through all of this anymore. Not in this case. So the simple thing to do is when you have a bracket, you multiply the two exponents, because basically what you're saying is -5, okay, in bracket, and that's to the power of 5. And then that number to the power of 5 is also to the power of 7. Simple way to do it is to multiply the two powers. So you just need to multiply those two powers. That will be 5, 7, 35. And you're just going to put the answer as -5 to the power of 35. And that's your answer. Okay? And even if you don't put the negative in the bracket, it's understood. So here we have two different, this is a fraction. So it's 5 to the power of 2. So let's write it out so it's easier. So 5 to the power of 2 over 8 to the power of 2. And each of these are going to be to the power of 4. Okay? So you just simply multiply that by that power and that by that power. And so the answer will be 4 times 2, which is 4 2's 8, so 5 to the power of 8 over 8 to the power of 8. Very simple. So let's simplify these exponents. So because we have numbers that are multiplied in the brackets, so everything must be multiplied. So we have 8 and 4 as whole numbers. So 4 times 8 is 32. So we know 4 times 8 is 32. And because we have two n's that are in like the variables, unknown variables, so when they're multiplied and we don't know what they are, we just put a square. So there, the answer is 32n squared. And here, this is not a multiplication sign. These are x's. So it's basically saying 7x squared. And we're going to multiply that by 7x to the power of 3. Okay. Okay, so another way of doing that, remember, when you have the base is the same and you're multiplying it, you just add the base. You just add the exponents. So in this case, we're just adding, and that's exactly what we did here because this was n to the power of 1. And then, so when we go back to this one here, so we said, let me just circle it. So this is the one I'm talking about right now. So if you notice that for n, that is an imaginary 1, power of 1 there, and 8n is, there's an imaginary 1, power of 1 there. That's why it becomes n to the power of 2, because you're adding the powers. In this case, it's the same thing, but it's just that in this case, we have power of 2 and a power of 3. So we're going to multiply the two base numbers, which is 7 times 7, which is 49. So we're just going to say 49, and then we add the powers, which is 2 and 3, which is 49x to the power of 5. And so that's what we do when we're multiplying. When we're multiplying same number with the same base numbers, okay? In this case, we're saying 32x to the power of 5, y to the power of 9, and then x to the power of 2, and then y does not have a power, it's imaginary 1. So another way of looking at it is 32x to the power of 5, it's easier to read, and then y to the power of 9, and that is divided into, as a fraction, 8 to the power of x, and then, sorry, 8x to the power of 2. I'm excited. And then y does not have anything greater than 1. Okay? Now, similar how we do our multiplication when we have the numbers have the same base power, or base, when the base is the same, we can do adding and subtracting. When we're dividing, we subtract the powers. When we're multiplying, we add the powers. So in this case, we have 8 and 32. So because 32 is divided by 8, so we're going to just say 4, okay? And because the base, we don't divide them, we just carry the base the way they are, but we just subtract the powers. So we have 5 here, but for the over the power of x, and then we have 2 to the for the power of x below. So the 5 is the numerator, the 2 is the denominator. So 5 minus 2 is equal to 3. And then 9, and then 1, imaginary 1 here. So 9 minus 1 is 8. So now y is to the power of 8. Okay. So when we divide, we subtract the powers. When we multiply, we add the powers. So let's go to scientific notation. So in the scientific notation, it's very easy. We just need to count how many zeros or how many places we have, and the number must be in the form of a ones, and the balance must be in decimal. So this number is 57. So with scientific notation, we always have the first number as, you remember when you do your numbering, your placement of your numbers. So in this case, your 5 must be in the ones group, and then anything after that must be a decimal. So the first thing we're going to say is 5.7, because that's the rule for scientific notation. It must always be in the ones, and the balance must be in decimals. So we're going to count how many ones that or how many zeros or values of whole numbers we would have had. So we know it's 3. Just going to come by 3. Plus 3 is 6, plus 3 is 9, and then plus 1 is 10. So we're going to say 5.7 times, and in this case, we always use 10 as our base when we're doing scientific notation. So we're using, again, 7. If you count from 7 all the way down, we have 10 places. So that means 5.7 times 10 to the power of 10. And in this case, it's the opposite, because if you notice, this is not a whole number, it's a decimal. So we would have to count how many decimal places we went to get the 9. So remember, we only need the first number as the one in the ones placement section. And we're going to use 9.52. Okay, so we're not using anything other than that. And all numbers that are not 0 must be included, okay, based on the placement values. So how many zeros did we move to? So 1, 2, 3, 4, and then the 9 make 5. Okay, so 1, 2, 3, 4, 5. So we move 5 times. So again, in this case, we're going to say it's 10 is a base always, but in this case, we went backwards. So -7. So we went -7 into the section where, so we went backwards, and then that's why -7 is the correct answer. And anybody who looks at this number, they'll know that the number is smaller than what it appears in the scientific notation form. Okay, so this is understood. So when it's a smaller number, it is expressed as a negative power. When it's a bigger number, it's expressed as a positive power. I know sometimes teachers don't explain these things that way, but I like to explain it very carefully so people can understand the differences. Okay, so here we just have a simple number 3x to the power of 2. So 3x2. So we're just going to say, what is the answer when x is 7? And what is the answer when y is 4? So we're just simply going to say 3, and we're going to substitute 7 for x, and then we're going to bring that to the power of 2. Remember, BEDMAS, you always do your exponents first before you do your multiplication. If you say 3 times 7, then you put that to the power of 2, that'd be wrong. So you have to first say, what is 7 to the power of 2? We already know if you multiply 7 by itself, it becomes 49. So then you're going to say 3 times 49. Okay? And then we're going to do our long multiplication. And I can just say, okay, if we did 3 times 50, it would be 150. And if we minus 3, that would be 147. And that would be the answer. Okay. I don't know if you understand what I did. So 49 only needs 1 to be 50. And I just simply multiply it by 3. And then I subtract 1 3 times, and I got 147. Okay. So let's look at 6 times y to the power of 3. So if we substitute 4 in the place of y, so again, we have to remember the rule. You're gonna have to do the exponent first. So we're gonna say 4 to the power of 3, and that answer is just to multiply 4 times itself 3 times. And then we're gonna say, okay, so we know that that's 6 times 64. And that would be our answer. So 6 times 64. And when we do the math, it's 384. If you're not allowed to use your calculator, then you have to do it in a long division way. Okay, 384. Now we're gonna do 2x plus 32x, and this is very easy. So we're not gonna be using this information up here because that was only for this set of questions, okay? So here we're just simplifying. We don't need to find out what x is. So when you're simplifying, you're just gonna add in this case. So this is just to help us to understand what comes next, because these are foundational principles that you need to know when you're gonna go into the more complex and more challenging questions. So here it's just 52x. That's it. Okay, you're just adding the coefficients. If you don't remember what coefficients are, is the numbers that are multiplying the variables, okay? In this case, we have 5x to the power of 2 plus x to the power of 2, okay? And again, you can notice that in this case, x to the power of 2 is the same base number, okay? So guess what? We're not going to add or do anything to the exponents. In this case, we're not multiplying the numbers and we're not dividing. When we're not dividing or multiplying the numbers, we're going to leave the variables exactly the same. The only thing we're going to care about is the coefficients. So in this case, we're going to say 5 plus 8 is equal to 13. And we're going to say 13x to the power of 2. That's it. We don't do anything with the exponents because we're not adding, multiplying, and we're not dividing. That's the only time you change your exponents. In this case, again, similar to what we did in section 1, we are doing 11x minus 6. So 11x minus 6 is, you just say plus, okay? Which is the, remember what I said about negative times a negative is a positive. So in this case, we're saying 11x plus 6x. So we're just saying it's equal to 17x. And that's all we need to know. When you have a negative together, it always becomes a positive. And that ends our session for our review for chapter 1, in chapter 2, and chapter 3 in the first one was operations, numbers and operation. The second one was rate, ratios, and percentages. And the third one is powers and monomials. Thank you for watching, and I hope this helps.